Every week, we just pick on one topic, we discuss on it, we share more lights on it, and see how we can add it to the current stack that we already have and see if anyone's using it. Just a session where we can all just get our hands dirty and learn something new.
That's a very relaxed environment, these meetings, and the subjects are challenging. Obviously, there are things that you might have not heard of them before. ICM was once a surprise for me, and I have to admit that I haven't heard about it. Not that I was alien the principles that were presented, but not to the framework itself.
It was new for me also. It is not that mainstream. We follow that guy on Instagram, and he took it to next level now. We are building it for other people inside Obsidian, and we just push everything inside Obsidian to a GitHub, and then our client can download the entire brain inside their local machine. It's following ICM, really interesting, but it was very new topic for me also. I learned a lot from that. And to be honest, it streamlined lots of my processes after that. It was good. All credits to our Andy.
So what are you guys working on right now? Manoj, are you working on something specifically? Although, what fills your workday?
So mainly our outcomes-based approaches is still there for last 3 years. Sales automations for speed to lead through voice AI or text AI or whatever the way. Then outreach, cold DMing, cold LinkedIn, cold emailing, everything through AI and lots of research. Before it starts, we have our data pipelines where we scrape the data and reach the data, lots of things there also. Then we have our sales people who do cold calling for us because we don't use voice AI for cold calling. Regulations and things are very strict here. So yeah, our tech stack is evolving. We used to do it with Go High Level, WAPI and lots of things. Now we've made everything around cloud. It become cloud AI operating system. Everybody is talking about that. I'm like, that's the natural next step for all the agencies to automate their own processes first. So we act like an agency, do custom solutions for small businesses, mid-sized businesses. Now we are on the path to be the partner. So we are opening up Claude Code certification. It's an exam. You pass the exam and then you got the certifications. But not everyone can go for the exam. You need a partner. Through them, you can apply for the exam. So we want to become that layer where small businesses, small teams, if they are not directly partnered with Anthropic and they need those certification to upskill their teams, they can work through us. But it's still very early stage. So we are in education, software agency. We are building lots of things for lots of different people in ourselves.
Could actually sound quite natural, or is it also just not as good? Is it better than VAPI or retail? Because I'm pretty sure that most people are using VAPI or retail at the moment.
I think it depends on the use case, but John is the right guy who will understand each and every element of the voice.
Okay. I was just going to say, in terms of performance, you can get parity with either one. When I said speed, it's more about speed of development because you can use agents more easily with LiveKit. It's definitely better than VAPI, I'll say. But retail's pretty decent, so you just need to get the right pipeline if you want to get better performance there. You have more flexibility to use the latest models.
What, you mean on retail, yeah?
Yeah, compared to retail, you have more flexibility to use the latest models on LiveKit and Pipecat because they build their integrations faster.
Okay. The reason that I use retail at the moment is because it really allows me to break down the prompt into different sections. And that way I basically have a split prompt for everything.
Yeah, that's one of the reasons I prefer access to low-level orchestration like LiveKit and Pipecat, because context management can be done at a much more sophisticated level on those. You can have much more advanced context management strategies where you're incrementally adding context or completely resetting the context. You have complete full control as you do agent handoff patterns.
Okay, nice.
Awesome. Okay. This topic in particular, I've been spending a lot of time on it. I'm still diving deep on it, but I just feel like it's just something that I feel like I could share with us, right? Because in previous sessions, we're always building stuff, and sometimes it's good to just take a step back and learn some terminologies, learn some things that we proceed, right? So I tried to water it down, but if you're really interested, I can send the link after this session so you can read more in depth and get more understanding of what we are currently going to be doing. We're going to be talking about loop engineering today, and loop engineering is a very interesting topic. If you've been in this AI space for a while, you have gone through the transition of prompt engineering to context engineering, and now we have harness engineering, and now we have loop engineering. So we just keep getting promoted from different engineering titles. But the whole point of this session is to give you an idea of what it is today, right? And how we move from typing prompts by hand to designing systems that do the prompting for you, right? So I'm just going to be talking a little bit more about loop engineering today. So 9 out of 10 builders have never written a loop. In fact, I was also part of the 9 out of 10 builders up until most recently that I got the concept of what a loop is. And that's the whole point of this session. Just like we had with the ICM framework, I want you to walk out of this session with a newer understanding of where things are going and with a better view about using AI, right? So I'm just going to walk you through it so you understand what it is, right? So 9 out of 10 builders have never written a loop, right? There's no automation, there's no state file, there's no verifier, there's no schedule. They just type, they wait for the AI to respond or to generate the code. They read the difference and they type again, right? And this is how it's been for a while. So for 2 years, the agent was just a tool, right? You held it the whole time when you were working with the tool. Every single time you're typing with the tool, you're getting responses from the tool. So everything happened while you're on the desk, right? But then we had a jump, right? We took it a step further to not only give the agent prompts, but to kind of design context around it, right? Because we realized that the prompt wasn't just enough. Giving zero-shot example was constrained. It wasn't just enough. The agent is only as efficient with the context that you give it. And then people started understanding the use case of a context window, right? So all of that, I'm going to try my best to explain this new concept as I'm grasping it as well, so you guys can get a better understanding of it. So yeah, so we move from typing prompts, right? With the classic ChatGPT, you type the prompt, the agent gives us a prompt. So with loop engineering, this concept, the team at Anthropic, they have been able to merge 8 times more code per day than they were able to do 2 years ago, right? And I think when that report came out by, I think it was someone that brought up the report, Anthropic said that it was an overstatement. But the truth is, even though it's an overstatement, the numbers itself are saying something, right? The numbers itself, they are actually pointing at the productivity gain to be quite high. So whether you want to debate the number or anything, the truth is that the mechanism behind it, it cannot be engineered, right? It cannot be fabricated. So this is what we are going to be talking about today, right? So there are 4 flaws of leverage, at least that's how I like to see it, for how we got to this point, right? And the first one, like I said, it started all with prompt engineering. And that was basically the words, right? What we were saying to the AI, right? You had to optimize how you ask it, right? You had to optimize what you tell the AI to do, how you put your words, how you structure the words. That was the era of words. You held the agent through every turn. And the skill back then was phrasing, how best you phrase your words. If you're using zero-shot examples, 1 shot, 2 shots, 3 shots, and then there was a chain of thought. So you have to think carefully through this process. You have to do this. It all worked with words. And then we took it a step further to context engineering, right? Because we understood that these AI models, they have what we call a context window, right? And it's just an amount of tokens that it can have within a session, right? And there was also something called brain rot. If you watched the previous series where we talked about context rots, like brain rots, right? The more you feed tokens into the window, the lesser efficient or effective its output is going to be. So we then understood that optimizing that window, right? Optimizing the amount of context that you give the agents was how you're going to get a better result. So people started optimizing what the model sees, the memory, the tools it's connected to, like MCPs and skills and all of that. That was what made the context, right? So we moved from the words And then we found out that, okay, we don't just need the words, we need to optimize the window, right? To optimize what we give the model. And that's where we were for, I'll say, a period of time until we moved over to harness engineering. And that's everything that surrounds the AI, that surrounds the LLM, right? So think of it like prompting is just the words. Context is connecting like more information, giving it ability to retrieve information, giving it memory and all of that stuff, connectors, skills. And then harness was everything around the runtime, right? Around the tools, around the feedback. This was what the models could do, right? And I think that's where OpenClaw and a lot of this other concept broke out, because they were able to figure out how to build a harness around these LLMs, right? So they were able to build what the LLM can do. Okay, if it's going to do web search, this is the tool it's going to use for web search. If it's going to run, it's going to run on this runtime. And people started taking pages of the book around harness engineering. And that's where we're currently at right now. Now, a new system has evolved, and that is loop engineering, which is the system. So now we're optimizing who does the prompting. So for the first time ever, we as the people that used to prompt are now being replaced by a system that does the prompting for us while we are off the desk. So it finds the work, it checks it, and it describes the next move. So just like the loop, it goes in through iterations, right? So that is how we've been able to move up one floor at a time. And who knows what next year is going to be, or in the next 2 years, right? So I want you to understand that the loop actually doesn't replace the first 3 floors I just showed you, but it automates it, right? Which is exactly why you can't design a loop that you can't run by hand. It is not possible for you to loop something that you can't draw a system around and build a step around, right? So everything that you're looking here from floor 1 to 3 is all tied into loop engineering. So I know it might be a lot to take in, but I promise you, if you stay with me, you're going to get what I'm trying to say. So each era, we raised where the leverage lives, and we pushed it further, right? It pushed you further from your keyboard, and it pushed you to a point where you're now 3 floors ahead of it, right? So let me go into each of them in more detail, right? As you can see here, first was hand on the keys. Then we started curating our inputs to ensure that the context was efficient. And then we decided to stay beside the loop. And now we're out of the chair. So loop engineering actually allows you to delegate tasks to the agents, and the agent runs the prompting, the checking, the decision, and try to ensure that it does what it's supposed to do. I don't know if any of you have come across the /goal or /loop. It's inherent in Anthropic, but I'm going to show you more on that. But if you have an idea of that, you start to understand where I'm going with this, right? I always try to tie in some of those terminologies when we're discussing, so you can start to get the picture, right? So I'm going to start from floor 1. I know I've already spoken a little bit about it, but I still want to just refresh our memories a little bit. So in prompt engineering, the unit of work was our prompting, the ability to write instructions, the ability to not be vague, to be more concise, to be more specific, to surround constraints, tell the AI what inputs, what outputs, and all of that. We hand over the context and we read what came back from the AI. If we're not satisfied, we reiterate and we write the next prompt, right? So we held the agents the whole time throughout this process. And our leverage back then was phrasing those words. Adding a few short examples. Role prompt: you are a professional email writer, or you're an expert at data analysis, and this is what you do, and this is what you do. So the skill was knowing how to ask the agent, right? And you were in the chair the whole time that you're working with the agent. That was, and I'm sure everyone here started off that way. Then we moved over to context engineering, what the model sees, right? Then it clicked that the model is only as good as what's in its window. That way, the leverage now slid off from the prompts and into the inputs, right? So everything from the write files that were pointed to the memory where the connectors live, all of these things. So the skill now became curation, being able to curate everything before passing it over to the agents. We stopped pausing over the wordings, and we started to choose what the model gets to see. And if you remember, this was very crucial when we talked about the ICM workspace, for those of you that remember, because the whole point of using that interpretable context methodology was so that we don't overload the context with irrelevant stuff. So this is still really preaching into that angle, right? Then we moved over to harness engineering, what the model can do. We started to give the model tools. We gave it the wrong time and a way to see what breaks, like Claude Code, right? So if you're running code with Claude Code, or you're working with Claude Code, has the ability to run bash commands, run terminal commands, list things, run commands to see what's happening behind the scenes, check the logs, decide on its own the next best action. So it's flawed, it's anthropic, but the harness around it is what people started to engineer, right? So you give the models the right tools, the ability to search the internet, the ability to run bash commands on your system, and the ability to read its own outputs, see what broke, and figure a way to fix it, right? So this is harness. That's what the harness was. This was where the first loop showed up first, right? This is where it actually came about, the first idea of a loop. Because with harness, we're able to run through different systems, but we could connect it back, right? So Claude Code, for instance, codecs are all harnesses, right? So the loop exists now. This is what we didn't have 2+ back, right? So you're just still standing next to it, ready to interrupt it when something happens, or steer it in the right direction, or feed it some more context, right? So that's basically how harness engineering worked, right? The harness gave the agents the ability to loop, right? It gave the agents ability to loop. And now with loop engineering, it takes you out of it, right? So like I mentioned, if you know about the /goal, it's a new feature that Anthropic gave. Before that, you will prompt, and Claude is going to work. Claude is going to stop. You review, you prompt again, and it goes around like that way. And at the end of the day, you are the bottleneck, right? So nothing moves without your input. And now with goal, if you have used goal, or if you know how goal works, it closes the loop. All you do is you set out a goal, right? And Claude works. And when Claude is done with the task, it's going to evaluate. It has an evaluator that checks what it's done and compares it with the goal. If it achieves the goal, it's going to stop. If it hasn't achieved the goal, it's going to run back in the loop, right? And it's going to continue doing those instructions. It's going to continue doing those things, right? Until the goal has been achieved. So the moment we were able to reach that point in technology, we removed ourselves out of the loop, right? And we only established a condition that until that condition is met, the loop will continue to move. It's continue working. So this was the first integration of loop. And when I first came across the /goal, I think codecs were the first people to bring it on. It was quite interesting. I was seeing a lot of people out on the internet saying how they were able to set out a goal and come back. But I really didn't understand the concept behind it until I understood what loop engineering is. And maybe in subsequent sessions like this, we'll go more deeper into them. But I just wanted to use this session as also a way to bring it to our awareness, right? So you actually know where we are currently at in the timeline of the whole AI buzz and where we're currently at. So this is loop engineering, right? Designing the system that prompts. So with loop engineering, the system finds work, it hands it over to an agent. This is actually what we would have done, right? The human in the loop. It hands it to the agent, checks the results, it records what happened, and decides the next move. The harness we just talked about. But all you have to do is you have to design it once, right? Then once it decides the next move, it then goes back to find the work, hand it over to the agent. The agent is done. It checks the results. When it checks the result, it records what happened and decides the next move to make. When it decides the next move to make, it then circles back. It looks back to find the work of the next move, and on and on and on. It does that on its own, right? You design it once, and the system prompts the agent from then on, right? The agent is going to forget each step because obviously the agent is just playing a role in the system, right? That is because the state file does not, right? So even if the agent forgets each run, there's going to be a state, which is what you're seeing here, that records what happens. So every single time there is a memory log, something is being recorded, right? So the state file does not. That's the whole concept of loop engineering. So this is the fourth floor. This is where we are currently at. And if you're able to understand the difference between prompt engineering, context engineering, and just harness engineering, and you combine all of them, and you now get the concept of loop engineering, it just changes the whole game and the whole way you understand AI, right? You start moving from just a builder to someone that can build systems that run autonomously. That's where we're currently getting to. But the next question, the honest question is, do you actually need a loop? I'm sure this might be great, but a lot of people might already start thinking, oh man, it's going to eat a lot of context. It's going to take a lot of tokens. It's going to take a lot of this and that. And it's fine. You can always have your own reservations and your own thoughts about it. Like I said, this is just to open your eyes to a new level of where we're at. So if you ask me, does everything need a loop? Just like we talked about dynamic workflows the last time, they are all for their own specific use cases. So there's going to be, I'm going to walk you through honest tests that we use to determine whether we should go with a loop or not. But so far, I want you to understand that the whole point of this is to give you an understanding before anyone starts to build, before you start building anything, you have to check if you pass what I call a 4-condition test, right? If you're able to pass the 4-condition test, then you actually do need a loop. But if you even fail one of those conditions, then I would say that the loop is not for you. This is just something that does not require a loop for as at right now. Okay. So what are the 4 conditions? I'm going to walk you through them. So the 4 conditions, if you miss one, just keep it within the manual prompting. But if you pass each of them, then it is a very good candidate for a loop. So what is the first condition? The first condition is the task repeats itself, right? So are we dealing with a task that repeats itself over and over again, like a skill? You remember when we talked about skill, it's just instructions that happen more often, and you just find a way to make it reusable. That's the whole point of the skill. So that's the first condition. If this task is repeatable, then it's definitely what they'll do. But the other 3 have to be satisfied. The second one is the verification. Can verification be automated? If the verification is automated, then that's the second point. So verification is automated. Then does the budget absorb the wastes? Because when you're running through loops, you have to know that it's going to run different times, right? It's going to run in different iterations and different increments of time. So if the budget satisfies the use case, then a loop is needed, right? If a budget justifies it, then it is valid, right? So as long as the budget is willing to absorb the waste, then it is valid. And then the last one, the agent has senior engineer tools. So if the agent is given senior engineer tools, and I'm going to touch on that as we go, those real tools, then it deserves a loop. So all 4 of these conditions must pass, or you keep it as a manual prompting process, right? So that's that for that. So move on to the next one. So loops favor whoever can spend, because like I said, it pays off, but it has to tick all those boxes, right? So you're going to skip loop for now if you're just a solo builder on consumer plans and the build lands before the payoff does, right? If you're doing this as a hobbyist, or if you're just, this is not something you experiment with unless you have a real use case for it, right? And like I said, the budget. Secondly, if you're coding with no automated verification, then the loop is not for you. You can skip it for now, right? And then if, like for instance, if you're working with teams whose bottleneck is review, not typing, then you can skip it for now. And also, if you're using it for one-off exploratory or judgment call work, then you can skip it for now. But who is it going to favor? It's going to favor people that are doing repetitive, machine-checkable work that also have the budget to run this. And it's also going to favor people with code bases that already have real test coverage, right? And also for teams that are already running multiple agents, like the dynamic workflows I mentioned, and like Anthropic's team that has been able to push 8 times the code that they used to do in the past, right? All of these things, especially, it usually pays off, especially if you're in the development and engineering space, right? Because you're going to go through thousands of lines of code and you're going to deal with large files, right? this is where the loop shines, right? This is where the loop shines. And my own honest take of it is that loop can favor whoever can spend, right? So if you're on a consumer plan, this might not be for you. And if your review is bottled by teams, if you need humans to actually check it, then this is not for you. This is only for people that have a repetitive and test covered work that already know how to do it. So to say it plainly, loop engineering is real, and most people in the room might not need it yet, right? So that's basically how I want to look at it, because from my own understanding and also checking the people that are currently using it right now in the industry, it's good to just know that most developers just don't need it yet. And that's just my own honest version, right? But why am I showing you this? Why am I explaining this to you? So when you get to that point, or when you actually are brought up with a decision and you look at the 4 conditions and say, hey, these steps are repeatable. This verification does not need to be manual. It could be automated, right? We have the budget to run these loops. And the 4th condition, which, like I said, the agent will also be given a senior role and the tools for that senior role, right? So this is only for engineering that actually recommends or requires a high taste and a high level of engineering skills, right? Which you're going to give the agent after all. So right now, we're going to do something live. I actually built a little repo for us to test. And while we're testing it, I'm also going to be walking you through different blocks of the loop. But before I go forward, does anyone have any question? I'll be willing to just take any quick question or anything that you want to ask before we proceed. I don't just want to keep blabbing and not hear from any one of you. So yeah, any questions so far?
I've actually asked a question in the chat.
Okay.
How do you relate the orchestrator of a workflow to what you have described? So if you're able to define a workflow with multiple stages, multiple crossroads where the flow can take various routes, and if you have that designed, does it relate to something that you're describing? I have a visual diagram that I've shared in the link that I've put in the chat. Just to better understand and connect to something that I've been doing for a while.
Okay, that's a good question. So if I'm getting you correctly, you're asking how to relate loop engineering to engineering and orchestration, right? Of a
orchestration of going through a workflow, a design workflow, which allows the activity to go on various routes and verify certain conditions for the next step and look at predecessors and upstream and downstream steps in a workflow and decide which way to go.
Oh, okay. So my understanding, I would say loop engineering is a single loop, right? Like a single loop that's end to end. But an orchestrator, what you're talking about, is more of like a loop of loops. And I'm going to break it down. I'm glad you already brought this up. But as we go through this session, I'm going to actually break down what makes a minimal viable loop, right? Like an MVP, but I'll call it an MTL, right? So it starts with 4 parts, right? One is the automation. Another one is the skill. Then the state file and the gates to check the loop before it runs to the next step. So that's more of the add-on. But when you're talking about an orchestrator, is what you get when you compose many of those atoms into a directed workflow, where the output of one loop becomes the trigger or the input for the next. Because from where you're coming, you're talking about something where you're running through different workflows and stuff like that. So I think the key distinction I would say is a single loop answer is this one task done, which is like the gates at the end. But the orchestrator was going to ask, what's the next task, given everything that's happened so far? So it's like routing, right? So loop engineering is more like mastering the gates, and orchestration is mastering like routing between those gates. So I don't know if that kind of gives you.
I think it's clear. Yeah.
Yeah. Okay. Awesome. Well, very, very good question. So I'm going to go over to. So I have something here. Let me see if I can pull it up. I'm also going to copy this prompt. Great. So while this is working, because I'm gonna actually run a loop right now, right? While it is running, we can then talk about the other parts of this session. So I'm just going to switch to Warp, the tool I use for coding or for prompting rather. And yeah, let's do it. Okay, so the first thing I'm going to show you guys a website that has been built. It looks finished. And I'm going to ask you guys if we should actually ship it. And then I'm going to hear what you have to say. I'm going to go into the demo. I'm running it right now. Great. So can you see this website? Just run a quick.
Yes.
Can you see it?
Yeah.
Okay. While you sleep, can you see that wrong? Your blah, blah, blah. So this is a website. So just like everybody that builds a website, before they publish the website or they can check off on the website, there's usually a command that they run, right? So if you don't know the command, don't worry. It's not really that important, but I'm just trying to show you what we're doing. So it's called run gates, npm run gates. Okay, let me just zoom in a little bit so you can see. But first, should I run this? Should I ship this? Just need one or two responses just to be sure you guys are following with me. Let's ship this.
No.
Okay, one no. Who else? Can someone else give me an answer? Come on, guys. Someone can just unmute. I just want to be sure you guys are following with me. Should I ship
I would make sure that there's another set, go, walk away, and then there's something else over there. Maybe go down a little bit on the website.
Okay, great. For like a one-page website, let's say I just want to put a one-page website. There might be some things on this website that are not really good, right? So the whole point of this is to run a gate. So this is the gate. So as you can see, we have some passes, we have some failures, right? And which shows that the website is not ready to be shipped. So you guys are red on that. That's why you see the gate is red. So out of 7 checks, we only passed 3 of them. We passed that HTML as a lang attribute. We also passed a non-empty title. We passed exactly one header 1. But we failed on a couple of things. So we failed on the responsive viewports, right? It's not there. And we failed on 3 feature cards. So we only found 2, right? But the spec documents actually wanted 3 cards. So as you can see, there's only 2 cards here. So the 3rd card is missing, right? And then also every image is empty. So I don't want to go deep into the code, but yeah, you can see out of the checks, we've never gone past 50%, right? So we only have 3. So four errors are going on here, right? So what do? I'm going to open Claude right now inside this report that I just went in. And then I'm going to paste in the prompts that I just got. This one. Right. I think I copied it already. So we're going to start the loop, and then we're going to keep what we're doing. We're going to keep going with what we're doing. So this is it. So /loop is going to run this in the loop continually. And then we put the /goal. So the goal of this is that it should run this command that it did, run this command passes, and check that all the spec.md rows are green. So you have to ensure that everything is green. Now, as a prompt engineer, if you're going to use prompt engineering, I'll have to go into each of this one and say, fix this and do this, and then get some response. Go back and do this, fix this, get some response. Then I have to go to the next one. Why are the 3 feature cards not showing? Can you investigate what's going on? It's going to pull out some errors or some. It's going to investigate the root issue, the root cause of it. I'll say, okay, can you like fix it or change this to this and that? I have to go back to the image. So I'm just trying to show you the amount of time that I actually have to be with the computer. I have to sit and talk to it. But right now, I put it in a loop, right? And I give it a goal that it should run this command and it should read the landing build skill that has already been built and fix the site, which is what you're looking at, to meet the spec, right? Update the state.md and open a draft PR when the gate is green. So that's all I'm going to do. I'm just going to click on enter and let it do its thing.
It's very similar to how we do automatic testing before deployment of a code.
Exactly. So while it's working, we can just go back to what we're doing. So I'll just go back to the slide, and then we'll come back to this. So it looked done. The website looked done, but now, like you can see, it has loaded the skill, landing build skill, and now it's reading the vision.md first. So it has started, right? It's going to be running the loop. So it wants to check the current page state.md. So it ran the command and it saw the current state, right? As you can see, it has checked the current state. So now it's now going to decide the next action to do. So the gate is red with 4 failures, missing viewports, only 2 card features, logo is missing, the email input has no associated label. All 4 are clear spec fixes. Let me apply them. So it has started, right? So it's doing its thing. Now the 3rd card feature. So it's going to just keep doing its thing while it continues. So 5 building blocks that make this thing what it is. The first is the automation, right? This part, right? They all speak like the same shapes. So whatever you see here are just examples. They are all like the same thing, right? So the automations, they fire on a schedule, on an event, or until the condition holds, right? So like this, the goal, it continues to run until the goal is met. The cron triggers on a schedule. The hooks triggers on an event. And the loop also runs until condition is met, right? So that is the first thing. That's the first building block that makes the loop engineering work, right? There's no loop engineering if there's nothing that automates or works round the clock, right? So that's where it starts from. Then the second one is the isolates, right? So you have to first have the heartbeats, which is like the automation. The second one is to isolate. So what is isolate? So you don't want the parallel agents to touch each other's code or to mess with each other's code. So there's something called work trees on Git, right? So it just pins up like duplicates of, let's say, certain code base. I don't want to make it really more complicated, but I think I have an image on my system that I had pulled out to show. So let me see if I can find it. So this is how Git work trees work, right? So this is the main branch. When you work with Git work tree, it's going to create another branch, right? An agent can work on this branch, focusing on a different feature. And then it's going to open another branch of another agent that's working on this feature. That way, as this agent is working, the second agent is not messing up with its own code. So it just keeps creating branch trees to isolate each agent to work in their own environment. So that's basically what this is. So parallel agents can't touch each other's checkout, right? So first you have the loop. Second, you have to isolate the work. And then you also have to load in the skills, like I just showed you with what's in when I was using Claude, right? So skills, which is something you guys are already familiar with, you've been following different of our sessions, is just the knowledge about the project that has been written once and can be reused every time. That is what the agents are going to use when they go into the work trees, right? And what will trigger the agents who go through the work trees is the automations, basically. The next is connectors. So what are skills without connectors? What are skills without scripts, right? Without tools to actually use, right? So that is how the agents that's how the agents are able to reach to get tickets from Slack. I could have made this example a bit more complicated, but I wanted to just keep it really simple, right? I could have created a loop to go check issues on GitHub, right? Any ticket that has been raised, and then investigate on it, try and check the code base and try and fix it. I could have also made it go through a repo or go through Slack messages. So that is how you're giving the agents reach to wherever they need to do it. So the skills give them the instruction, the tools give them the reach. And then we have a second opinion. If you remember when we talked about dynamic workflows, and for those of you that weren't here, dynamic workflows just another feature that was created on Anthropic, a way to spin hundreds of agents, right? Giving them their own context window, their own fresh context to carry out different tasks. So there was a condition that we mentioned, right? That we never allow one LLM to be the maker and checker of his code, because these LLMs can be very biased towards their own outputs. And for some time, anytime I take an output from one agent, I'll ask the agent, what do you think about this? And this is perfect. This is spot on. It will praise its work, right? And the moment I take that same output to ChatGPT or another model, it highlights all the errors. It starts to point out that, oh, this is wrong, that is wrong, this is wrong. I say, okay, can you give me a list of everything that needs to be worked on? And then it provides that list. And I take back that list of suggestions, of mistakes, and I feed it back to the model that created it. And it's like, wow, whoever gave this instruction is very intelligent. And I'm like, yeah. So what I'm trying to say is, we always need a second opinion, right? We always need someone with a neutral mindset, a neutral position to be able to assess what the agent has done. So that's where sub agents come in. So we have a maker, we have a checker. In coding, you have the code, the agent that writes the code, you have the agent that reviews the code, right? And then finally, we have the spine. So what is the spine? The spine is the state file. That's what allows the loop to run in a continuous loop and being able to carry the memory or remember what happened previously. So the state file just record what's been done and what is next, right? So this is the only thing that survives between each run, right? So the state.md is where all the states are going to be written. right? The skill.md is the skills, and this is the building blocks, right? So if you understand, and I'm sure everyone watching this understands to at least 90% of everything here because we have used them one way or the other previous sessions. But this is this is the building block that makes this happen, makes this possible, right? So I'm going to just take a peep. I think, yeah. So it's done, right? So the gate is green and I can run another. Let me exit, or let me just run it here. You know what? I'll just open it in the tab. Wait. Okay. So if I run the gates here, see, everything has been passed. As you can see, it's green. So the loop ran everything. And if let me just open it and so we can see. It involves. You can see the third card has appeared and the label is working. So now it is ready to be pushed. Now it's ready to be shipped. So this is just like a simple example of not being the one to prompt, not being the one to engineer, but be the one to assign the task, assign the loop, assign the goal, right? So I assigned the automation, which was a loop. I assigned the condition, which was a goal. And it had access to the skills, because this time we didn't use the isolate work trees. We had access to the skills that it used to work. We didn't need any connections, right? But we had access to a second opinion, and we also had access to the state. So let me walk you through that in the previous. Just go back to the previous. I think it's this one. So as you can see, I'm just going to try and run you guys through it. It loaded the skill, right? It read through the states, the state.md. It read through the state, which carried the last run, right? The last run was 3/7. It started the progress and it completed it and it recorded everything here. And this were the lessons learned. The page can look finished and still fail the gates. The gate checks everything, right? The spec MD is the contract. So these are the conditions, right? Look at the condition. The stop condition was the /goal, right? And it exits when all the spec rules pass. So the only time the goal will stop, the only time the loop will stop is when all of them pass. And it has to be verified by a separate checker, right? So it checked the states and see what's failing. When it saw what was failing, it started to implement the fix. Started with this one, made the fix. Started with this one, make the fix. Started with the index, make the fix. Went here to change the ID, made the fix. Now, if we run the gates to verify that all of them were passed, and when it ran it, it came out. Let me just expand it so you can see. Okay. Where is that? Okay, okay. So it ran it, and all of the gates, it was green. So exit 0, and it was verified by another checker, right? Like I said, they have another checker, which is this one, right? So the checker confirmed that it worked. Oh my God. Can you guys hear me?
Yes.
Okay, good. So when it verified, it updated the state.md and then opened a draft PR. So it updated the states and made a draft, right? So I'm just trying to show you everything worked on a loop. And then the agent came back and told me that the loop's goal is achieved. I'm stopping here, right? So done, the gate is green, the draft has been opened, everything without me even lifting a finger, right? Then it walked me through all the fixes that it did. So because the verification was automated using the checker, right? It did not need any person in the loop to check it, right? Because it could be automated. All you just have to do is to check if the pass happened or not. Because this was a repeatable step, and because it needed skills, right? The skill was the senior developer skill I just mentioned, like the skill to build the website. Those were the things that we needed, right? It needed the skill, the senior role skill. It needed a state file to know what happened before and what's happening next. And it survived the run. It also needed an agent to check. It didn't need this because the skill did not need any connect. So we didn't need to pull information from any third-party app. And it also needed the heartbeats. So this is what creates a loop. So loop engineering is the ability to create all of this structure and design it once so that you don't need to do any work again, right? You can step out of the chair and then loop runs continuously. You don't need to come back and say, no, fix this. As far as you set up the goal and the goal has not been achieved, the loop will continuously run. I'll keep going this way. So this is the most useful split, right? we keep the maker away from the checker, right? Because like I mentioned, in order to prevent LLM bias, we have to ensure that they don't have any access to, it's neutral, right? So the input was a task. It generated the code. It writes the code. There is another agent that evaluates the code. It critiques it. If it's wrong, it's going to reject it and give feedback. And that feedback is fed back to the generator. And when it then accepts it, then it pushes it out. So the model that wrote the code is way too nice when it's grading its own homework. So none of this is new, by the way. We already know this, right? So using the evaluator and optimizer pattern or the maker checker, it ensures that your code doesn't have any flaw, right? We've all seen what worked, right? It looked done, but the gate knew it wasn't done, right? So the gate was a hard gate that kind of stopped us, right? So what we did was we ran it, it reopened it, and when we reopened it, we saw the third card. Guys, we saw the card. I mean, refresh it, and you see the card is there. So yeah, and the states.md was a loop that wrote its own entry, right? Just because the agent is going to forget when the next run happens, right? So the state is what reminds the agent or brings the agent up to speed, like with the ICM workspace, where when you load the runtime, it goes through the first layer, which is the Claude.md, to know where it is. Then it goes into the context.md to know where to route for different intents, and then different steps, different workflows. If you are not part of that session, I would really recommend that you watch it. That's one of it opens another world. A lot of people have mentioned it here already, so I can't even emphasize it even more than this. But yeah, so that's this state.md plays a crucial role for every time the agent has to run through the loop. So I have to point out that the loop didn't need taste. It needed a role that could say no. The maker wrote it, and a separate checker checked it to confirm that it was green.
Hey, Andy, can I ask you a quick question?
Yeah, please go ahead.
So basically, in the context of a website, I can actually see this and I have a human eye. So I know what's appealing to my eye and what's appealing to most of the other humans, right? So how does AI know what is actually working? Because at the end of the day, unless you install Playwright or some kind of web checker for itself, and then it basically has the permissions to build the website on a local host and then actually look at that website, it's not really going to know what the problems are with the website. That's why you will always need a human reviewer, right? So in that sense, what really is the point of a loop if I'm going to have to review it anyways?
Okay, so I don't know if you know about automated web testing. Have you heard of that concept before?
Yeah.
Okay, great. So I'm glad you asked that while I switched to this slide, because now I'm going to actually take more time to break it down for you before I go about this part. So whenever you create a website, let's say you're running an e-com website, there's a lot of things that go into an e-com website, the payments, the input labels, the site has to work, all the buttons have to navigate and stuff like that. Whenever you're building a website, you're always going to have a checklist for every feature on your app, right? Okay. You're going to have the feature that goes through the payments, the checkout, the carts. So for every session or for every feature or for every page that you're going to develop, you're going to have a test checklist that you can either use Playwright to create like some sort of system to run through it, or you as a human would have to verify it, right? Starting from the login page when you get authenticated and go back and forth. So now you can actually do that with the loop. You just have to engineer the use case or the test that you want the agent to do, right? So for instance, if I was to design a loop to automate the testing of a website, I'm first going to list out all the pages and all the user journeys on the website, right? And with Playwright, you can automate, or if you're using Chromium or Chrome Dev MCP or any of those tools, you can automate mouse clicks, keyboard inputs, and all of that stuff. You can then create a system, an automation, or a loop in this case, to run through each of those checklists and ensure that they work, right? So the loop is not going to stop until each of them work. So for instance, it goes to the checkout page and it finds out that you can't log in. The login is not returning anything. It then goes into the code to find out why it's not working. And then it fixes that and runs the test. When it runs the test again and it passes, it goes to the next step, right? And from that, the next step. It only works when the loop only ends when the goal has been achieved. So, like you said, you need a human to verify it. But at the same time, if you give the agent a skill, if you give the agent a playwright skill to spin up the browser and actually do those manual clicks and manual, like I did that for one of my automations the other day. I had the agent go through a checklist, and this was without loop, by the way. The only difference was the agent will run and give me the result for that build. And then the agent can also say, if you want to verify it, here's the step. Click on this localhost, put your email, put your password, click enter, go and check your Superbase table that your user ID has been logged in. Because he did that with Playwright. But imagine now I have a list of 100 things to check. Then I'll put a loop, and all I have to tell the loop is the gate is a checklist. As you can see, the gate is the test, the build, or lint that fails bad on its own, right? So when it fails, it can say no, right? If it fails, the agent can say no, you have to go back and fix it. So the agent generates a new code, another agent checks the code and verifies that it has actually been fixed before it runs the test. When it runs the test, it works, it goes to the next one. So instead of pointing to just one thing, with the loop engineering, you can point it to everything that makes up your website, every human interaction, every click, everything, right? For instance, the website I just showed you before, it didn't have, this is just a simple example, right? I could have written something like this and it will work. But now it won't work because we've inserted the email, right? So imagine, let me just put this, it worked, right? It's just a simple website. There's no success rate, but it worked. It didn't give you any errors. So in loop engineering, you will have the tests, you have the acceptance criteria. So all you just have to do is point the agent to the checklist. Hey, I have a checklist of 100 steps. Go through each of them and ensure everything is working. And then you wake up to see that all the checklists have been passed. And you can go ahead and verify it because it has been passed and all the results have been recorded. I don't know if that answers your question. I know I spent a lot of time here, but I deliberately wanted to ensure that you get the point. Or does that make sense?
I get the fact that we can actually automate tests, but ultimately the final verification, I'm guessing, especially for a website, has to be by a human. If it's more programmatic in nature, I would say that the loop is good. But in terms of a website, I'd still prefer to check it myself.
Sure, you can definitely check yourself. And if you remember, when I talked about the 4 conditions, right? Verification can be automated. That's when you need a loop. But let's say you part of the verification still needs a manual, then you might not need a loop.
Yeah.
But if you ask me, if all you need to do is ensure that buttons are clicking and sending data to the right endpoints, and when you log in, the flow of the screen, the user journey is seamless. There's no error. It's also going to check for error messages, right? Like let's say you put in a wrong card detail, right? There are also tests for that. You don't just test for all the success messages. You also check for error messages. So the AI is going to check the message, check what it's supposed to show, like the acceptance criteria. And if it does not align, that's going to be the hard no. So that's basically how it works. Back to what you just watched was a minimum viable loop, right? I had one automation that fired on a cadence and stopped on a clear condition. So the automation was the loop and the condition was the goal. The goal was to ensure that everything checks as passed, all the tests are passed before it ends. The skill was the skill to build a website, right? The website building skill, basically. So the project context, the agent would otherwise rebuild from zero every one, right? So this was the context that the agent would otherwise use to rebuild from zero every run. And then the states, right? It was done, and what's next? So tomorrow it resumes instead of restarting. And then, which brings me back to what we talked, the hard gates, right? With the point of satisfaction, the point where the human can say, yes, this is working. So the same thing you're looking to achieve or accomplish when you do your human test, you can program that into the gates, right? You can program that into the gate. So this is basically what makes the loop. So first you have to get one manual run working. When you get the run working, you can turn it into a skill, right? And then you can wrap it in a loop. So for the test that I did, I got it working. I didn't convert it into a skill because I was just testing it I was just testing it one off. So basically what I built something that could go on some manual websites that don't have APIs and fill in some information for me. And it did that and it logged the information and I checked and it worked, right? The next step I would have done was to turn it to a skill. So I don't have to start prompting, open Playwright, click on this form, fill it with this information, click on submit and get back to me. All I just have to do is use this skill to fill this thing for me. It already knows when to click, what to check. And then I've created a skill. And if I want to take it to the next step, I can wrap it in a loop. I say, fill in all my information from now till a certain time or to a condition. Or I can tell it every day, every single day, fill this thing for me. So I don't have to come every single day and say, use my skill to fill this. Every day it wakes up, it loads my skill, and it confirms at the end of the day if everything has been logged, then it shuts down. Then the next day, it wakes up, it runs that skill, it has an automated checker to confirm that it has been logged, and then it ends the skill. So the order isn't optional. And the number to watch is basically like the cost per accepted change, not the tokens spent, right? So like I said, you have to ensure you have budgets for this, right? Sorry guys, it's raining really heavily here. That's why I have to raise my voice so I can actually get myself. So that's basically what creates a loop, right? An automation that wakes it up, a skill that allows the agent to do what it's supposed to do, a state for it to record it. So every loop, it understands what was done in the past and what it's supposed to do. And then it records what should be done next. And then the gates, which is just the verifier to determine if it's done or not. If it's not done, it's going to send it back to fix it and stuff like that. So yeah, I'm going to just wrap it up very soon. I don't know if you heard about the Ralph Wiggum loop. It was trending really well. The Ralph Wiggum loop, it fails quietly and it spends loud. So that was like the trap. Like there was no real verifier in between the Ralph loop. I heard a lot of great things about it, but eventually I started seeing a lot of people complaining about it, that it always had a soft done condition and there was no hard stop, right? The system was working. Yes, you could look through a lot of things, but there was no hard stop. There was no condition that ended it, right? And that way the agents sometimes call the end of the loop too early. And sometimes the loop exists with half done work. Or sometimes you can keep spending until someone outside notices it, right? It keeps spending a lot of tokens, a lot of costs. And the fix was a gate that can't fail you. It could be that a test passes, just like I showed you in the example, or it doesn't. It could be that a bill compiles or it doesn't. So what you don't want is a second agent that just has an opinion, right? You need a second agent that tells you, no, this is not it, run it back. So it's all the same thing, right? It's all the same at the end of the day. So the goal will run the vision and you're going to take away the self-flattery using a separate checker, right? So the long runs are going to be handled by reading the vision every single time and getting away with LLM being biased with its own output is handled by a separate checker. And the laziness of partial work or the agent exiting too early is covered by the /goal objective. So it always checks the goal to determine if the work is truly done or it's not. If the goal is not done, it's going to run the loop back, right? So the AI doesn't get lazy. The AI also doesn't flatter itself because it's another AI that's going to check its output, right? And the agent is not going to drift on long runs because it has a vision.md, right? It has something that keeps it running. So that was like the fix for the Ralph Wiggum loop. That was the fix for the Ralph Wiggum loop. So yeah, I have talked about how the loop works in a lot of details. I've spoken about how the loop works. Now I'm just going to talk about the cost, right? So the faster the loop ships code that you didn't write, the wider the gap between what the repo holds and what you understand. So the depth of comprehension is the depth now. You have to be able to understand and read through the difference and more like spot check, right? So keep the loop of the architecture, keep the loop of things that need a judgment call, and let the loop run for things that, like I said, are verifications is automated and doesn't really require a human in the loop. You need a human in the loop for the architecture. You need a human in the loop through the payment, through sensitive stuff like that require a judgment call, right? But you can put the loop through security checks, right? Through audits, through re-audit permissions, right? That is where the loop will really work out. The whole point of what I'm trying to say is that yes, the loop can work and it can take a lot of work off your plate, but there are some things that you still need to do, right? So then secondly is the security task. A loop running unattended is an attack surface that's running unattended. So, and review PRs, skills that have like injection vectors, secrets in the logs, and permissions that quietly creep in, right? Those are the things that you have to ensure that when you're running a loop, it has to be attended. You can't run a loop that is unattended because there could be a lot of attack surfaces. There could be corrupted skill. There could be other things that you might need to keep an eye on, right? So as much as we want to delegate stuff to the AI, we have to ensure that we are also following best practices. We are also being cautious of what we give the AI the control over. I'm always going to advocate for using AI ethically and safely, right? Not just letting it run and do everything for you. So yeah, guys, like I said, this is the takeaway, right? This is the takeaway. So the first is that how do you know if you can run it on any task? There's a loop check, right? You have to have a 30 seconds, what I call it 30 seconds loop check, right? So if the task happens at least weekly, then you can actually give it a 30 seconds, a type check, a build, or a linter that can reject like bad outputs, then you can give it a loop test. If the agent can run the code it changes, then you can give it a loop check. If the loop has a hard stop, which it could be a budget, it could be a time limit, it could be an iteration count, then you can run a loop, right? And at the end of the day, you have to have a human in loop to review before any merge, before any deployment, or before any dependency change. So these are 5 checks. You just have to build small and ensure that you are following up. Because if you miss one, you have to, like I said earlier, if you miss one of the 4 conditions, then you have to keep doing it manually or prompting by hand, right? So that's basically what I'm trying to bring to your notice, right? So this is a new floor that we are standing on today. I walked you guys through the 4 floors, how we got here. We all started with the prompt engineering and it moved all the way to context, moved all the way to harness engineering. And this is where we're currently at right now. So that is it. The leverage has moved, right? And as leverage moved, your job also did too, right? So right now, what we are doing is building the loop and staying the engineer. But first, before you even understand the concept of loop, you have to know how to master the 3 floors first. To build the 4th floor is only when the test says yes. Only when the test says yes. So I'll come back again and show you the test. These are the tests, right? If the task repeats itself, then it needs a loop. If the verification is automated, then it needs a loop. If the budget can absorb the waste, then it needs a loop. And then finally, if you're going to give the agent skills to carry out all these tasks, then it needs the loop. Guys, so if you don't know the remaining flaws, like I mentioned, then you do need to watch a previous series, watch what we've been doing for some time. You can always check in with us. You know, our school community where we have about 2,500 people, we always share things like this. We always come along to build stuff. And we recently launched Claude AI OS, where we build operating systems for AI, right? And we also touched a bit on some of those things, right? We talked about the brain, and we took a page out of Andrew Kapati's LLM wikis, the prompts, the idea behind that. We built a second brain. Then we also built an OS for the agents to now be able to work with the brain, share the brain, and use it to carry out other outcomes. We also talked about ICM, right? The folder as a structure for agents. We talked about a lot of things. And next month, we're going to be doing a 3-day sprint where we're going to build an AI OS from start to finish. In case you missed any of the sessions, we're going to do a 3-day sprint where we start building the brain, we build the OS, we build the ICM workspace structure, and we hand it over to you guys so you guys can understand how it works. So I think I'll leave that for Manoj to talk more on. But guys, this is something that was really fascinating the moment I looked into it. And I had to be real with you guys. I had to tell you that, yes, it is great, but it's not everyone. So you have to ensure that it ticks all the boxes before you can do it. So I took a page out of a very interesting thread that I read. This was one of the things that kind of pushed me to study this. And I'm going to put a link in case you want to take a look at it. I'm just going to, let me share this other screen so you can see it. I'm going to this link in case you want to look at this thing. It's going to talk about it more in depth. Like I do every time, I like to show you guys because I know some of you are really curious and like to dig deeper. So the same way I did with the article for ICM, I'm going to put this one here. For those of you that didn't get the ICM, this is the article. This is the article. This is the repo. This is the article. You can just come here and read it. We touched on it the last time, but I didn't want to just read through pages, so I created my own presentation out of it. But if you remember the structure, this is how it works. And this is the workspace structure. It can be applied to anything. So yeah, I'm just going to drop this in the chats. I'm going to drop both of them in the chats for those of you that probably want to take a better look at it. Oh, okay. You didn't see this part. I was sharing this screen. Let me show you that again. The ICM. Okay. Okay. So you remember the ICM? This is the repo. Thought you guys could see it. And this is the document, right? So interpretable context methodology, folders as a structure. This is, if you remember, the layers are the same way I broke it down, right? Layer 0, where am I? Context, where do I go? The stages, what do I do? The reference material, skill.md, you get, if you understand the concept of that. And then this is the structure, right? It can be applied for anything. This was applied for, I think, research, scripts, and production, maybe a slide or something. I used my own different use case. So you can always take a look at this if you want to dive deeper. You can also take a look at the loop engineering, right? This puts it in more detail. So again, I'm going to just copy that and put that in the chat for anyone that's interested. But yeah, as always, I'm really glad to have you guys here and brainstorm and do things together. Certainly always a lovely time. I'm going to hand it over back to Manoj so that he can wrap things up. So yeah, Manoj, over to you.
Okay, thank you. But first, if you guys have any question, you can ask down. Okay, thank you, John. And thank you for joining.
Yeah, of course, my pleasure. This was great.
Awesome.
Yeah, thanks for that, Andy. It's all great to hear, man.
Awesome.
Thanks. But when I was seeing this, I thought that what if we give it non-technical tasks like scraping and reaching and those kind of loops where you don't need any human review, you just need quantity and very well research of the prospects or let's say any company intelligence, those kind of things, so that it keeps running in the loop, checking it's on, and those kind of things may have less security than the code and all these activities and some back office automations. And Mihaya asked a really good question about the difference between the deterministic workflows and the loop. I see like it's quite similar. For example, our, let's say, speed to lead example, when somebody fills a form, it is an automation. Then it goes through the person information in our CRM. That's a context. And then it goes and calls the person. That's an action. And then it moves back to the next person. So it deterministic workflows looks like loop, but now we have lots of AI into it, sub agents, skills, those kind of things, which makes it pretty advanced. And I saw that lots of people were worrying about that this thing burns lots of tokens, and it is good for companies who can afford those tokens.
Yeah. So what you asked is a very good question. And I'm happy you brought it up because I know I emphasized on engineering because that was like most of the use case I saw was engineering, which I said justified the budgets, right? But at the end of the day, if you are going to use it for non-engineering tasks, like specifically, it also maps cleanly into it, right? And I can show you 3 pieces that map cleaning into it. For instance, the gate. Remember, the gate is like a hard check where it can actually say no, or it can actually, move on to the next step. So for the example I showed, we had a gate with pass and fail rules. So as long as it's failed, you keep running till, everything is passed, right, Manoj? For non-engineering work, you will need an equivalent of what a done is. You need a definition of done. If it's lead enrichment, maybe the definition of done is we have 50 leads, each with a company plus a verified role plus a reason to reach out, right? And none of them should come from excluded industries. Imagine we had like some excluded industries. So what the script can do is count the rows and check the required fields that they are not empty. That could be the gates. It could be something like every record has an email, a LinkedIn, a company size, and funding stage, right? And all the email passes like the delivery check, like their deliverable, right? For research, it could be like every claim should have a source URL, right? And they should not be older than a certain time. It's harder, but it's still gateable, right? So as far as you can define the gates of what you want, I showed you the 5 building blocks. As far as you can have the gates, which is the hard yes or no, that can work. And the state.md it lets the loop resume and also allows it to avoid redoing the same work over and over again. So for lead generation, that can become leads that have already been contacted or has already been enriched, or it could be sources that have already been checked. So each run continues without duplicating the first the same thing. You don't have the agent checking the same lead and all of that stuff. And then you can have something like a self-pacing or like a scheduled loop, right? So you can use the loop, you can use a schedule, it doesn't matter, right? Or you can just say enrich 20 leads every morning, or keep researching until you have 30 cited findings, or pull this data source and pull new leads from it. So whenever you run the loop, it does that every single day. Once the gates, which is 20 new leads, have been done, then it gets those leads and it completes the stuff. So it's the same recipe, right? Define a falsifiable spec, define something, write a checker, right? And loop until the thing has been done. So that's basically it. The only difference is in this case, you have to connect tools like vibe prospecting. If you know that tool on Claude or Apollo, you're going to have like web search. So you're going to connect tools that gives you the data sources, right, for you to do it. So yeah, my honest review of it is, as long as the work has a definition of when the work is done and it can be defined, then we are good to go. But stuff like writing an email, right, writing a compelling email, personalized email, maybe you might still need a human in the loop before you fire that off, right? Same with having the code, but before you deploy it, you run through, you check through it. But every other thing can be looped. So yeah, to any other person that was thinking about that, because I know that thought also crossed my mind. You can also find a way to loop through that. Yeah.
So whatever you want to automate, it can be through loop, and loop is kind of a self-improving kind of a system, which deterministically applied. Let's see how it.
You guys look into it. Take a look into it, especially for Mihai, that you work with a lot of code bases. You're definitely going to not regret having the loop, do stuff for you.
Yeah, if you had asked me if I would like tomorrow morning to take what you've presented and maybe bring it to another level, I would probably look into human in the loop engineering into the loop. What does it mean? It means that you need to have some plausibility coefficients of verification. And if the loop considers that they are within certain limits of plausibility, they don't need to ask the human for feedback. But if the plausibility it's important how you define it and what are the parameters for it. But once the plausibility falls below a certain level, then the loop stops instead of going further and says, no, I need to ask the human. And then the human is prompted, and then the loop goes on. And if it doesn't find any next point where the plausibility falls below the threshold, then it can go on and finish without any interaction with the human until the end. But that engineering the human in the loop, inside the loop, would be something that I would consider probably more deeply, just as an idea.
Yeah. It's like having best AI loop kind of thing. Right? It's interesting. You can share on next workshop if you come up with something innovative. Okay.
Yeah, I actually see a world where both can actually exist, where you have a hybrid, like you mentioned. They're gonna be some part that you need a human checkpoint, right? Let's say out of all the 1,000 steps, you need a human to check 4 or 5 times. So the human is going to have a checkpoint. When the human confirms it, then he runs the other part of the loop.
Actually, I'm talking about something slightly different. It's about not have deterministic human checkpoints, but has the algorithmic determination if a human checkpoint is needed or not. And then have a dynamic human in the loop interaction depending on the outcome of the verification at various steps in the loop. So if they don't go above a certain certainty or plausibility level, then the human needs to be brought into the loop and to validate or not, or give more instructions or whatever. And then the loop can continue from there. So that's way more dynamic.
It's making decisions when to involve human rather than
Yes, exactly. Which is not deterministic. It might be or might not be the case, but that's a next level of engineering the loop by considering the human in the loop and where the human might be needed and what based on what logic should be the human be involved or not at various steps of the loop.
And logic varies based on what kind of task you have in the hand. Like Ravi wanted to see the output at some point where it can say, okay, this is more pleasing to human. It keeps fixing the errors and then it calls Ravi, okay, so is it good? Then
right. Like, yeah. What Andy said, like basically every morning I want you to search for 20 leads, for example. I've basically created an agent that will actually go into Apollo. It will like download maybe like 20, 30, 40 leads, whatever. And then it will enrich it with like Apify and whatever it is. And then I just say it will give it back to me. However, you can always, like with that loop, I can just say run this agent for this spreadsheet, you know?
Yeah.
So for example, the thing that I've done right now is that I've basically searched for hotel buyers and sellers for one of my clients. And what I do is that every morning, the agent will basically go ahead and like search for kind of leads. It will download them and it will enrich them and it will like get them ready, right? So what I'm thinking of, like, instead of like doing this loop, I'm just going to have like a list of people on the same as with my SEO agent that isn't finished yet, by the way. With my SEO agent is that I've got like a list of customers which have their own websites which are built for them, and it will go sequentially every Monday, and it will go through the entire flow of the agent, which that's the idea, right? But SEO is just proving to be a little bit more complicated than that. But the idea is the same, right? Like every Monday or whatever it is, I have this thing that will essentially run every week.
We have routines. Like I have routines on my cloud and inside my local machine also. So it's the thing you were talking about, more relevant for routines. You don't need much of the things there. So loop, if you start loop, it will burn lots of tokens. So routines is kind of a loop.
Like a heartbeat, yeah?
It is a routine kind of a thing.
Yeah.
I really have to go, but it was great speaking to you. I'll see you on whenever we meet again. And thanks for everything, Andy. Really, it's really great chats every time.
Right. Thanks, man. Thanks, man. John.
Yeah.
I haven't heard John's voice. So John, is this like a concept you've probably heard of or seen before?
Yeah, absolutely. So I was wondering to what extent I can remove myself from my own human development process, actually. And it sounds like actually we're on the same page. It's really interesting how like so many engineers have come to the same conclusion and have developed the same processes independently. And actually what Mihai said about like sort of having a coefficient where you can determine whether or not you should be checked in with, this is something like I've explored and haven't actually gotten to work because it requires judgment. And like the term coefficients suggests this is a continuum, but I think it's actually more of a binary. And I have to keep myself in the loop when it comes to brainstorming, specification, review, but the actual implementation, that's where I just let the agent run.
Yeah.
That's actually very interesting. So at the end of the day, the architecture and the part, like especially the planning, the brainstorming session, you want to take as much control of that because that's where your judgment calls and a lot of things like are put into play. And then the automated testing, the automated implementations of the plans you've written, that can now be automated with the goal feature. Like go ahead, your goal is to ensure that this plan has been checked out of the box. Yeah.
Yeah. And I think we work with human in the same way. Like the core team design the vision, then we delegate this to a group of developers and they decide, okay, now I need to talk to manager for this decision. So I think we are moving into that direction without having human teams. We have a team of agents on loops or routines.
You want workflows. It just keeps going like really. It's really interesting, guys. Once again, I really appreciate the time and I hope you all learn something. I hope you can all take this and make our own versions of it, make our own experiments, come back the next day and say, hey, we tried this. And it always gives me a lot of joy when I see people come back and say, we implemented this and whoa, it took us to the next level and stuff like that. So really appreciate you guys. Thanks for joining. And we're going to release the dates for the sprints soon so that everyone can be a part of it and we can all build our own OSs and make things happen.
Yeah, this was an interesting suggestion for me. In rapid strategies, there are 32 loops and they are brought into by the orchestrator into that workflow. And I realized that I intuitively designed the loop with checkpoints and actions to apply corrective decisions when needed inside each of the loop. But I haven't been very systematic, and having your presentation would make me a good opportunity for going back and maybe even better design the architecture of each loop in order to be able to be more consistent across the 32 loops which are interacting based on the workflow which is orchestrated by a master diagram of logic of the entire process. So that's interesting. Yeah. Thank you very much. It's very useful.
Great event.
Oh, guys, no problem. Next Friday, I'll always be on the hunt like I always do. Like when I see something, I'm like, yes, this is what we're going to discover this today. So yeah, I really appreciate guys. Yeah. So catch you on some other time. It was nice seeing all of you, familiar faces. Always great. So yeah, thanks guys. Really appreciate it.